Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
That if you enable synchronization rule in BGP, then within an AS, I mean for IBGP, like for an example, you have configured IBGP, but it will also be mandatory to configure IGPs along with IBGP. It will be mandatory. Like for an example, now I'm on R5 and by default synchronization rule is what? Disabled. See, show IPBGP. Check it out. It is best. All of them are best. No problem at all. Everything is fine. Next hop is reachable. Everything. Now what I did, router BGP 200, and then I said synchronization. This time I have enabled the synchronization rule in this BGP over here. Fine. And you see, remember the rule, I mean this synchronization, I mean if you change this synchronization rule for your BGP, then you have to perform hard reset. Otherwise your changes will not take place. You see, still they are best. Say clear IPBGP star. If you say in, then also there will not be any impact. See, you have to say, I mean you have to perform hard reset. So it will break neighborship with all neighbors. Re-establish it. Show IPBGP. Are they best now? Now they will not be best. So according to the synchronization rule, whatever you have learned via IBGP neighbor, you must learn the same prefixes with using IGPs as well. So now it will be mandatory to configure IGPs over here. It will be mandatory to configure to run either OSPF or AICRP or RIP, I mean RIP over here. Now that's fine, that we know very well that what is the effect of synchronization rule. But why BGP, I mean why this rule was developed for IBGP neighbors? Why this rule came into the BGP for IBGP neighbors? Tell me. Not loop prevention. Say to to remove black holes actually. To remove or to prevent your I mean in transit AS to prevent your transit AS from black holes. To prevent your transit AS from black holes. How? And remember, nowadays we are not using this rule. You know why? Because nowadays we are using MPLS, and MPLS have configured BGP free backbone. Means in backbone you will never configure BGP. But in MPLS there will not be any black hole, because data will be forwarded based on MPLS. But previously when MPLS didn't came into the market, when MPLS was not present into the market at that moment, it was required to have this rule, synchronization rule. But only for transit AS, only for transit AS. So in all transit AS it was required to enable this rule of BGP, this IBGP synchronization rule. It was mandatory. Otherwise, see what can happen in your network. Just try to understand. I will draw a diagram, right, and I will try to explain you with using that diagram only. MS Paint. See, let's say this is customer site A is giving this prefix to R1, R2, R3, R4, and then R3 is connected with customer B, and this is AS, one AS actually, AS 100, and this is what? ISP. So customer A is connected with ISP, customer B is also connected with an ISP. Fine. This is one AS, right? So you decided, what you decided over here, actually you configured AS 100, and then you also configured OSPF here among all routers, OSPF 1, area 0. And then you configured a loopback on R1, you advertise it into the OSPF. You also configured one loopback, another loopback, you advertise it into the OSPF. And then you configured IBGP peering in direct neighborship with using their loopback address in between R1 and R3 only. IBGP neighborship. You understand? With using their loopbacks. Now, you configured eBGP neighborship between customer A and R1, and also you configured eBGP neighborship with in between R3 and customer B, and this R3 is placed at the end of ISP. Now there is a prefix behind A which is 10.1.1.0/24, and there is a prefix behind B as well which is 20.1.1.0/24, right? They are, I mean, these are their lane networks, lane prefixes. Now definitely this R1 will advertise this prefix towards its eBGP neighbor R1. Now R1 is having another IBGP neighbor which is R3, so R1 will give it to R3, and then R3 will give it to customer B. So finally customer B will learn prefix coming from customer A, and in same manner customer B will advertise its 20's prefix to R3. R3 was eBGP neighbor for customer B, and then R3 will advertise it towards R1, and then further R1 will advertise it towards customer A. It means these two customers A and B will access their prefix with each other. But will it be really possible for them to communicate with each other over here? Just wait for a moment. Just try to think about it. So this AS100 is working as transit AS for these two customers, right? So will it be really possible for the lane users of customer A and B to communicate with each other? You know why? What will happen over here? If customer A is transmitting data towards 20's prefix, so customer A learnt it from R1, will send the traffic towards R1. R1 learnt it from R3, but still traffic has to go via either R2 or R4. Once traffic packet will reach either R2 or R3, R2 or R4, they will drop it. Because R2 and R4 do not have these prefixes available inside their routing table. So this is what black hole in transit AS. But in case if you are advertising BGP synchronization rule over here, if you are using BGP synchronization, of course for R3, R1 is what? IBGP neighbor. So R3 will not make this 10's prefix as best prefix which was received from R1 until unless it starts to receive it via IGP. IBGP synchronization rule, if you have enabled it over here. So of course for R3, R1 is what? IBGP neighbor. R3 is receiving this 10's prefix, right? See, this 10's prefix is coming on R1, then R1 is giving it to R3. R3 is receiving it from its IBGP neighbor. Now if synchronization rule is enabled on R3, then the same prefix must also receive via IGP, and if it is not receiving same prefix with using IGP, which is OSPF this time, it will not make it best. And if it does not make it best, how will it be possible for R3 to advertise it towards customer B? Are you getting my point or not? In same manner, if 20's prefix is advertised from B, customer B to R3, R3 will give it back to R1. Now R1 will receive this 20's prefix coming from IBGP neighbor R3, but R1 will not make it best until unless it starts to receive the same prefix with the help of IGP. I mean 20's prefix must also receive via OSPF as well. Otherwise it will not make it best. And if R1 do not make this prefix 20's, I mean 20.1.0/24 as best prefix, then it will not advertise it towards customer A. So if you have enabled synchronization on R1 and R3, this time customer A and B will not be able to exchange prefixes with each other, right? So now because synchronization rule is there, so you know very well that what should happen over here, right? So you have to redistribute BGP into OSPF, so that now R3 will receive this 10's prefix from R1. R3 is receiving 10's prefix coming from R1, and also it will start to receive that same prefix with the help of OSPF as well. Now that this for R3, that 10's prefix will become best prefix, and then this R3 can further advertise it in the direction of. But this time because R3 have also started it to receive via OSPF, it means this time this 10's prefix will be present on R2 as well as R4, because now it have started to receive it via OSPF. It means it is giving now guarantee, because if it is available in the routing table of the IGPs, it means it will be available on all routers as well. Try to understand. If R3 have started to receive this 10's prefix coming from R2 and R4 via OSPF with using OSPF, it means it is also available on R2 and R4 as well. So there will not be any black hole now. So now it will become best for R3, and then further R3 can advertise it in the direction of customer B. In same manner, 20s will be followed. 20s prefix will be followed. Are you getting my point or not? So according to the BGP, IBGP synchronization rule, if you are receiving anything from one of the IBGP neighbor, then you must receive the same prefix with the help of IGPs as well. Like this one. What will I do? I will move on R5. I will say router BGP 200. I'll say no synchronization, and then I'll say wait, just for a moment, right? I will show you that it will become best for R5 now. Show IP BGP. It have came up. See, all of them are best. Fine. Now R3 is getting this prefix. Once the prefix of 11111. R3 is getting prefix 11111 coming from IBGP neighbor R2. Now you do one thing, move back on R3, and on R3 you do one thing, do show IP BGP. See, this is best now, right? This is best for 11111. Now say router BGP 200, and then say synchronization, and then say clear IP BGP star, and then you will see that for this 11111 will not be best for R3. And if it is not best for R3, see 111 is not best. And if it is not best for R3, this 111, how will it be possible for R3 to advertise it towards R4? And how will it be possible for R4 to advertise it towards R5? So you move on R4 now, show IP BGP. You will not get that 111 over here. And also you will not get this 111 available on R5 as well. Oh my god. Of course you will not get this 1111 on R5 as well. So that's the problem now. How can you solve it now? By implementing IGPs. Like you can implement here, like in between R2 and R3 I can enable EIGRP, router EIGRP 100 not assembly network 23.1.2, and in same manner I will move on R3. I will say router EIGRP 100 not assembly 23.1.3. Neighborship will come up. EIGRP neighborship between R2 and R3. But still I have not redistributed BGP into EIGRP onto R2. That is why here, if you see show IP route EIGRP, is it there? Is it receiving anything over here? Show IP BGP, have it defined best this 1111? Not now, right? So move back again on R2 and do one thing. Say router EIGRP 100, and then say redistribute BGP 200 metric 1544010 0245 and 1500. Fine. Now move back again on R3, show IP route EIGRP. Check it out. It have started to receive. Tell me. It have started to receive this 111 via EIGRP. However, in its routing table, it will install this route via EIGRP. But now, if you check its BGP table, it will become best. However, it will show you RIB failure, but at least it will become best. So if it has become best, and also this R3 is having this prefix available inside its own routing table, so it will start to advertise it in the direction of R4 as well. See, via BGP. So it will happen over here. So if R3 is receiving anything from R1, the same prefix information must also receive via OSPF. If R1 is receiving anything from R3, then R1 must receive same information with the help of OSPF as well. Otherwise, it will not make it best. This is called synchronization rule. But nowadays it is no more in use. Nowadays it is not longer in use actually. We are not using it anywhere, because nowadays we are using MPLS. You will be using BGP only on edge routers. On core routers you will never require to enable BGP. But still, those core routers can switch your data based on MPLS. There will not be any black hole. So previously, when we were not having MPLS, then in that case, in that situation, this rule was really important, and it was by default enabled at that moment. Now it is by default disabled, because nowadays it is not required to enable synchronization anymore. Of course, and otherwise how will it be possible for R2 and R4 to switch your data if they do not have route available inside their routing table? Do one thing, either enable BGP on all devices in fully meshed or perform redistribution. But in case if you are having fully IBGP neighborship, then also, and in case synchronization is still enabled, then again you will require to perform redistribution along with fully meshed IBGP peering as well. Because rule says that if you are receiving anything from your IBGP neighbor, it will not make it best unless it starts, it receives the same prefix via any other IGP. So I hope that you people have understood the uses of synchronization. Fine, very good. Now, once again, I'll configure indirect neighborship. Indirect neighborship in between R1 and R5 itself. Indirect neighborship. So again, I will require to configure any IGP between them so that they can form IBGP neighborship, right? Indirect neighborship, fine. Because if they do not have reachability with each other, how will it be possible for BGP to form peering? Hey, if you are going to form indirect neighborship in BGP, whether it is IBGP neighborship or EBGP neighborship, then at least those neighbors must be reachable to each other. If they are not reachable to each other, then definitely it will not be possible for you guys to form neighborship. Fine. No router BGP 100, comma, do no router BGP, and also no router EICRP 100. In same manner, move on R3, no router EICRP 100, no router BGP 200. On R5 also. Fine. I wanted to configure IBGP peering in between R1 and R5 this time. So I have to configure any ICP between them. So let me configure EICRP router EICRP 100 node of something network, and then so EICRP will get enabled onto these interfaces. See, same manner on R2, router EICRP 100 node of something network. Ping. Fine, no problem related to reachability. Now I'm going to configure IBGP neighborship in between R1 and R5. So I'm on R1. Let's say we have configured router BGP 100. Sorry. Neighbor is what? Remote AS will be, and then 4.5.5.5 update source will be loopback. Move on R5. Neighbor, remote AS will be, and then update source will be. Fine. Neighborship will come up now. Neighborship will come up. See. Now I'm having one loopback over here with 50s network. I will advertise it into the BGP table. Router BGP 100 network 50.1.0 mask will be /24. Fine, it will be advertised into the BGP table. Finally, it will give it to R1. On R1 also, I will create one another loopback 10 IP address 10.1.1, and finally I will advertise it into the BGP network 10.1.0. Mask value will be, see, first of all let it receive all information from its neighbor. See, 50s prefix is here, 10s prefix is directly connected to R1, then it will give this 10s prefix to R5, and 50s prefix is directly connected to R5. Fine. Now, as you can see here on R1, show IP route, that it is having 50s prefix available inside its own routing table, and you must see that. Where is that? AD value is what? 200. And now on R5 you must have this 10s prefix available inside its own routing table. So I hope that you have seen that. This is, and next hop is what? 1111, is not it? Because we are getting it from neighbor 1111 only. So now you can try to communicate with 10.1.1 when source is your loopback 50, because 50's network is directly connected to loopback 10, sorry, loopback 10 on R5 itself, right? So are they communicating with each other? No. You know why? Whenever it will reach R4, it will drop it. And this time you are getting request timeout. You know why? Because R4 do not know that how to send unreachable message back to 50.1.1.1, because R4 doesn't know even about 50's network as well. But if you try to ping your 10.1.1 without specifying your source, then you will see that R4 will be having returning path, so you will get U. But this 50's prefix is also not available on R4. Previously in source I was taking 50's prefix, 50's network. So even R4 was not having that how to send unreachable message back to 50's network. Have you understood it? So still there is a black hole, big black hole. So they are exchanging their prefix with each other, but still they cannot communicate with each other. To solve this problem now, we can use GRE tunnel. To solve this problem, again we can use here GRE tunnel. And you can use GRE tunnel whether your neighbors are IBGP neighbors or eBGP neighbor, doesn't matter. So this time I'm going to use here GRE tunnel. So what will I do? I will move on R1, because I know from R1's FA0/0, even from the loopback of R1 I can reach the loopback of R5. So I can configure tunnel in between R1 and R5. So what will I do? I'll create one tunnel interface here. I will allocate an IP address from 192.168.1.0 range. Fine, and tunnel source will be my own loopback 1, and tunnel destination will be, and then move on R5. Interface tunnel 1 IP address 192.168.1.2. Tunnel source was, and tunnel destination was, ping 192.168.1.1. Of course, from tunnel to tunnel you can communicate with very easily without any problem. You understand what I mean to say here? See, what will happen actually if you move on R1 and if you check that 192.168.1.0 is directly connected to tunnel interface. And you know very well that whenever any packet will go through the tunnel, another extra GRE as well as external IP header will be added onto it. And in that it will be having source as 1.1.1.1 from here and destination as 5.5.5. So of course R2 have that information that how to reach 5.5.5 and how to reach 1.1.1.1 as well. I mean R2, R3 and R4, all of them. That is why it is possible to reach from R1 to R5 with using tunnel. Now what can you do actually? Show IPv6, check it out. To reach 50's network, right now its next hop address is what? 5.5.5. Do one thing, use route map or whatever you want to use, but configure its next hop address as the tunnel address of R5. Configure its next hop address as the tunnel address of R5. So whenever this router will send any traffic towards 50's network, it will send the traffic via tunnel interface, and then you know very well that what can happen. I mean what will happen. Try to understand.
Able to reach the
Because we can easily communicate via tunnel interfaces, right? So here you do one thing, to reach 50's prefix from R1, modify its next hop address and configure its next hop address as the tunnel interface of R5. So now do it on R1. Configure one route map, next underscore hop, commit 10. Don't match anything because you will apply it for all, and then say set IP next hop is what? Tunnel interface address of R5. And then do one thing, router BGP is 100, neighbor is 5.5.5, say route map, name is in which direction? Do clear IP BGP star. Now check is BGP table. In same manner, move back on R5. Do show IP BGP. To reach 10's prefix, its next hop address is 111. Make it tunnel address of R1.
सर एक बार R1 से पिंग करना होगा.
Wait.
एक बार please.
What?
R1 से पिंग.
So what will happen?
वो देखा जाए.
Returning path will not be there. Packet will come here, but return path is not available over here. Even R5 will give it to R4, but R4 will drop it. Reverse packet will be dropped. You can come from R1 to R5 now, but R5 will give it back to R4, but R4 will drop it here. So now create one another route map over here. Let's say Cisco or CCIE permit 10 match. Don't match anything. Say set IP next hop as the tunnel address of R1, and then router BGP is what? 100. Say neighbor 1.1.1. Say route map CCIE in which direction? So do clear IP BGP star in do show IP BGP. Check it out to reach 10's prefix, and now ping 10.1.1 when source is loop back 10. And it can be done in case of both, like IBGP as well as EBGP. Finally, you have to modify your next hop addresses. Finally, you are taking your traffic via tunnel. So these types of black holes can be covered with the help of GRE tunnel. You could also do one another thing over here, like configure tunnel interface, remove BGP, configure tunnel, and then configure BGP peering with using their tunnel interfaces itself. Then you will not require to configure these route maps and all. Are you getting my point or not?
Yes, sir.
Apart from using these route maps to modify your next hop address, what can you do? Configure tunnel interfaces first, and then configure BGP peering with using tunnel addresses itself. So their next hop will be tunnel addresses only by default. Have you understood it or not? So on R5, do show run pipe section router BGP. This is your configuration now. You just applied route map. You just configured route map only. Understood? So this is that how can we use GRE tunnel, or how can we implement BGP over GRE tunnel. So I hope that you people have understood it. And also you can configure BGP peering over tunnel interfaces as well. So even you can move back again on R1, ping 50.1.1.1, and source is its loop back, repeat. Performance is slow because encapsulation and decapsulation is done by devices. Addresses as well. I have recorded this diagram into video now, so draw it and try to memorize its IP addresses as well. Okay, one more thing in between. See, inside the internal network of this customer, OSPF1 area 0 is configured, and IP addresses are something like that. That in between R1 and R3 we are using 192.168.13.0/24, like 192.168.13.1 on R1, 13.3 on R3. Then in between R1 and R4, 192.168.14.1 at R1, 14.4 on R4. In between R1 and R2, in between R1 and R2, it will be, it's recording, 12.1 and 12.2. In between R2 and R4, it will be 192.168.24.2 and 24.4. In between R5 and R6, 192.168.1.56.5 and 56.6. In between R4 and R6, 192.168.46.4 and 46.6 at the end of R6. And also they are having one loopback interface, loopback 0. 150.1.1 on R1, 150.1.2.1 on R2, 150.1.3.1 on R3, 150.1.4.1 on R4, 150.1.5.1 on R5, 150.1.6.1 on R6, and they are reachable with each other with using their loopback addresses. OSPF is configured over there, and then accordingly we can configure BGP here. Of course, BGP will be required. It will be required for us to configure BGP at least on R5 and R6 because these are edge routers. And for customer, we are using BGP AS65500, whereas Sprint is using AS21545, and BT will be using AS35500, whereas New router will be using AS8127. When IP addresses are public addresses, they are already configured. You can see them. That's it.
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.